All right, welcome to lesson 2.4 in calculating correlation. So in the last video, we talked all about correlation, how it measures the strength and direction of a linear relationship between two quantitative variables. Now we're going to focus on calculating it. So recall this was the formula for correlation R. It was kind of a complicated formula used with z-scores and summing up the multiplication of all the z-scores for each point, and it gets a little bit complicated. So trust me, you'd rather rely on your calculator to find R for you, or it will just be given to you. So let's make sure we talk about how to find it on your calculator. So the first thing you have to do is you got to make sure you get your data entered into the calculator. Okay? So to enter data into the calculator, as we talked about in the calculator video, hit Stat and then Edit. This is where you enter in your data into the calculator. You'll notice I have some data entered in there into list 1 and list 2. Now you can use any list you want, but for this video I'm going to use list 1 and list 2. Now, once you do this, you can actually enter in the data, or once you actually enter in the data, you can actually take a look at a scatter plot too on your calculator, which is pretty cool. So we're going to do that as well. And then we're actually going to show you how to find the R value. Now, another important thing I want to remind you of is please, under mode, if you didn't do this already in the beginning of the year, please make sure Stack Diagnostics is turned on. That will definitely affect what R, if it finds R or not. I'm not quite sure what Stack Diagnostics is, but I know that if it's off, you cannot find R in your calculator. Kind of weird. All right, so let's actually look at some data. So here's some data I put together for us. We got X values and Y values. I kept it very generic just for the sake of doing it. And I actually already made a nice scatter plot of it. But what we're going to show you here is how to get the calculator to make a scatter plot of it. So if you could please go to Stat, Edit. If you want to pause the video right now and go ahead and enter this data in list 1, enter the X values, and in list 2, enter the Y values. Please make sure that you type them all in correctly and that they all correspond. Remember, each of these values go together. Like this is 20 and 84. That is an X and a Y measured from the same individual, so they have to be next to each other. You can't have any of these all flip-flopped or in any order you want. They got to correspond with each other. So the 41, the 105, that was measured from the same individual. So make sure they're all entered in there. All right, so if you need to pause, go ahead and do so now. All right, so once the data is in there, the first thing I want to show you is how your calculator can actually make a scatter plot for you. So once again, hit Y equals. This is where you go to graph things. But remember, Y equals is where you graph equations. We're not graphing equations in this class, so make sure all that is cleared out. Then what we want to do is we want to hit second Y equals to get to our stat plots. So please make sure plot 1 is turned on. And then make sure we select the little scatter plot here. The little scatter plot is the one that, well, looks like a little scatter plot. Don't just highlight it, but make sure you hit enter on it as well. All right, now it's going to want two lists. It's going to want your X list and your Y list. So make sure you type in the appropriate values here. So our X list for me was list 1. So I'm going to hit second number 1 to get list 1 pulled up there. And the Y list was list 2. So I'm going to hit second number 2 to get that pulled up there as well. Now, if you use different lists, you would have to change them according to the list that you use. But again, I was using list 1 and list 2. Now for the mark, you could use any mark you want to represent your dots. I'm just going to stick with the little squares there. All right, once all that's good, you can always hit second mode to quit out of there. But remember, we want to hit zoom and then 9. Anytime we mess with our stat plots, we want to hit zoom 9 to zoom in on our stats. So zoom 9 is zoom stat. And there we get a nice picture of this scatter plot. And it looks actually very similar to what I have on the scatter plot that I drew here in Excel there. But you see this nice scatter plot. All right, so just looking at that, you could talk about the shape. I'm sorry, not shape. I was thinking about data for a second there. But you could talk about the form, which it looks somewhat linear. The strength, it looks pretty strong. It's not the greatest line I've ever seen, but it looks pretty strong. And it looks linear. And it also looks positive. So it appears that as X goes up, so does Y. Now what we want to do is we actually want to calculate the correlation. And this is how, this is what this whole video is about, calculating correlation. Trust me, you don't want to bother finding z-scores for all these values, multiplying them all together, adding them all together, way too much time. So here's how you find the correlation. So what you want to do is hit Stat, and we're going to slide over to Calculate. All right, now, there are two things here that are very similar. There's number 4, which is linear regression, AX plus B, but we actually prefer number 8, which is linear regression, A plus BX. So please remember, always use A plus BX. In later videos, we're going to talk about what the A and the B are, but for right now, we just care about R. So again, select number 8 there. Now when you do this, it wants to know your data. Where's your data coming from? So once again, it wants to know the X list. So I'm going to hit second number 1 for the list 1 there. The Y list is list 2, so second number 2 there. And then leave the frequency list alone. Don't worry about storing the equation. We'll talk about that later. Don't worry about it. You just want to hit calculate. And it will tell you everything you need. Now in later videos, we are going to talk about A and B. and we're even going to talk about R squared. But for right now, we care about R. So the correlation for this data is 0.8780. I won't go around to the 4 decimals there. So 0.8780. That is how we get correlation here. So the correlation R is 0.8780. And it's positive. Clearly, we see a positive trend here, and it's fairly strong. 0.8780 is pretty strong. I mean, it could be a little bit better if some of these dots were lined up a little bit better, but hey, the data is what it is. No data is perfect, and that is how you find R. So go back here. I did write all this down for you here. Stat, calc, linear regression, A plus BX. Make sure you tell it which list you need, list 1 and list 2, or whatever list you use, and everything should be there. Very, very simple to get the correlation. It's actually a really nice feature of your calculator. All this other stuff on the screen here is going to come in handy as well real quickly, but pretty easy to make a scatter plot and find the correlation of that scatter plot for you. All right, now outliers do affect the correlation. There are all sorts of outliers that we're going to talk about in this video. An outlier is a point that doesn't seem to fit in with the rest of the pattern. Note that no set of data is perfect, so they must be very clearly not fitting the data. Just because a point is a little bit off doesn't necessarily make it an outlier. So we want to investigate how these values, if added or removed, impact the correlation. All right, so here's the first outlier we're going to talk about. Okay, so if this is my data, and as it is currently right now with these blue dots has a correlation of 0.9. What if I were add to this point right here? All right, now this point is an outlier in both the X and the Y directions, right? So not only does it's further away from everybody's X, but it's also further away from everybody's Y. So it's an outlier in both X and Y directions. Now this actually strengthens R. This is going to make R go up, right? I don't know exactly what's going to go up, but maybe 0.92. The point is that R is going to increase. Why? Well, keep in mind here, this point fits in line with the data. If anything, it extends the pattern. It makes the pattern look like it's going to elongate, continuing this trend that is constant, right? As X goes up, Y goes up at this constant rate. And when you add a point like that that fits in with the data, it's going to strengthen R and increase it. All right, now another value that we could add in is an outlier like this. Now a point like this is an outlier in the Y direction only. So notice that in terms of X's, oh boy, I cannot spell sometimes, in the Y direction only. Wow, that is really bad. I just feel awful. But anyway, you'll notice that in terms of X's, it's actually not very small or very large. It's actually kind of almost right in the middle in terms of X's. But in the Y, it is way, way, way higher. So its Y value is much larger than everybody else's. This is going to weaken R. Okay, this is going to pull R closer to 0. Now again, not a ton. Maybe it's going to reduce to 0.80 or something like that. Actually, it might not even make that big of an impact, but it is definitely going to weaken R. It's going to pull it closer to 0 because again, it doesn't fit the pattern. So that is definitely an outlier again in the Y direction. It's going to hurt your R value. All right, let's look at another one here. Another one would be an outlier in the X direction. So it would be like this type of point right here. So notice in terms of Y, it's actually right in the middle of all the Y values of every point. There's a couple points with bigger Y values, a couple points with smaller Y values, but it's an outlier in the X direction. I'm going to do my better here to spell that correctly. So it's an outlier in the X direction. Now this is also going to hurt your R value. I mean, just think about it. Doesn't fit the pattern, right? As X goes up, it actually looks like the Y value went back down. It wasn't falling into that constant rate. So this is actually going to decrease or weaken our R value, okay? So again, what would it become? Again, it's not like it's going to drop to 0.1 out of nowhere. It's probably just going to go down a little bit. So maybe 0.86. It's only 1 point. If there were a bunch of points falling over there, then it would really weaken it. But you get the idea. Now this last point I want to talk about is actually not really an outlier. I mean, it's just a new point. And that would be a point that just fits in with the data, right? Like right there. If I were to add a point that just fits in with the data, if anything, this is going to increase or strengthen your R value. Because this value fits in line with the data. It's like adding another point that makes sense. As X goes up, Y goes up. So adding these types of points in help you out. They make your data stronger, more convincing. So those are all good points that strengthen your R value. So those are the different types of outliers we have. Outliers in the X and Y direction actually make your strengthen you, right? They make you more valid into the future as you look more and more as X goes up, Y goes up. It just shows that it's really working into the future or into larger values. Outliers in the Y direction weaken you, outliers in the X direction only weaken you, and then points that just fit in line with everybody else, they're actually going to make your R stronger. So that's it for correlation. Hopefully this problem was nice, this video was nice and easy for you, and that you really understand correlation and using your calculator to find it. We're going to use our calculator a lot over the next couple of lessons, so make sure you know how to use it.